Greetings. This is a rapid review of what I think you should have learned about classes in Intro Java. I think it'll be clearest if you follow along with an example. Remember, a class is like a blueprint that describes a new data type for Java. This is a data type just like an int or a string or a boolean, except the difference is that these data types will let you create objects that can store lots of pieces of information and that can also run commands for you that are related to the objects. So you can think of them as little software models of something that you want to be able to interact with. We'll be creating a software model of a bank account. We'll start with one that's insecure, and then we'll sort of secure it. I think you'll get a lot more out of this if you follow along together with me in Eclipse. So here I've just made a kind of throwaway project. I'm going to create a new class, and I'm going to call it BankAccount. Public class bank account. So the first thing to know is whatever you've named your class, that's going to be the name of your data type. So I'll show you in a second. Let's create some client code that is like a piece of code that will let us test this bank account blueprint. So I'm going to create a second class over here, and I'm just going to call this tester, and it's going to have a main method. I think it's nice to pull this tab so that we're looking at these things side by side. So this is going to be the blueprint for what does it mean to be a bank account. And then this is a tester where I'll use that blueprint to actually create a bank account object and do things with it. Because I've already declared this bank account class, I'm actually allowed to say bank account, and create a variable whose data type is a bank account. It's highlighted in yellow because it's saying we're not doing anything with that variable yet. Notice that this is the same pattern as saying like int n. Here n and account are the names of the variables. Int and bank account are the data types that those variables contain. The way that you'd assign a number to n is you'd put equals 2. The way that you assign a bank account object to this variable is with the equals operator, but then you say new bank account. This is a special method called a constructor, which creates a new object using this blueprint over here. Right now the blueprint's empty, so it hasn't really done it. So let's turn our attention over here to what do we want this bank account object to be like. The first thing you need to decide are what are the facts that you need to record about a bank account? What does it mean to be a bank account? So I think that there are at least two important facts that we need to have. One is maybe the name of the person who owns the bank account, and the second is what's the balance? How much money is there? So usually you declare these variables up at the top. These are called instance variables. They're sometimes also called fields. So I said this was going to be insecure, so I'm going to do this. Public means that anybody can access these variables. So public double amount is going to be the amount of money I have in the account. And then public string name is going to be the name of the person on the account. Alright, so back over here in the tester, if I'm creating a new bank account, how do I tell the bank account how much money is in it and who owns it? The answer is this special method called a constructor takes as input the facts that you want to assign. So here, for example, I'm going to have the name on the account be Mr. D, and the amount of money in the account is going to be $10 to start with. Okay, now it's highlighted in red because we haven't actually created this special constructor method. Remember, everything that we do with the bank account has to be declared here inside our blueprint. So that's the second thing. The first thing is these facts, the instance variables that describe the bank account. The next thing is public bank account. You're creating the constructor. The constructor is a very special method. Notice that here I don't have any return type. I don't have int. I don't even have void, which is what you would usually put if your method didn't return anything. By leaving no return type at all, that's one of the ways that the blueprint knows that this is the constructor. The other way is this name has to match the name of your class exactly. Alright, so inside the parentheses, remember I need to declare the parameters. That's the variables that are going to hold the inputs. So over here, I'm trying to call my method with two inputs, a string and a number. So over here I need two variables in the parentheses, a variable that's a string that will hold the name, and a variable that's a double that will hold the amount. Okay, so these variables here are temporary variables. They only last as long as this method runs, and then they stop existing. So the job of the constructor is to take these inputs and to assign the values to these variables up here, because these instance variables are the permanent variables that record facts about our objects. So I'll say, well, it's a little bit awkward because this is called amount, and this is called amount, and that's called name and name. So it doesn't make sense for me to say name equals name, because it's like, am I taking the value in here and saving it there, or am I taking the value in here and saving it in here? So we're going to use a special keyword called this. The keyword this refers to whatever object is running this code. So you can think of this as referring to the instance variables up here. And look at the colors. This.name is blue, and this variable up here is blue. And here name is brown, and this input variable here is brown. So this.amount equals amount. All right, so that's the second thing. The constructor has taken inputs and it's assigned values to the fields up here. An important thing to know is you don't have to take inputs for every single variable here. I could leave amount out, for example. Let's say you have to create the bank account first and it automatically starts with $0 in it. So here I'm only taking a name as input and I assign the name, but then amount gets a default value of 0 assigned. So that's also possible. Let's go ahead and change my tester over here to reflect that. Alright, so the last piece is we have to have methods. Methods are either questions that you want to be able to ask your object, questions like how much money is in the account, who's the name on the account, or commands, commands like you want to deposit money or withdraw money, or maybe change the name on the account. There's special names for some of these methods. Getter methods are methods that let the tester get the values inside these variables. So for example, let's say over here in my tester, I wanted to be able to see how much money is in the account. I don't really have a good way of looking at the amount variable here. I can't say system.out.println amount, because amount is a variable that only exists inside your bank account object. So I can't access it from out here. So that's the purpose of a getter method. A getter method will let you take your account object and ask it a question. And the question is, let's get the amount of money. I don't have to call it amount. It doesn't have to match this variable name. That's not special. I could call it whatever I want. I could call it like get balance, for example. And then you'd create it here. Public double, because it's going to return a double. It's going to return the amount of money. And then get balance. And it doesn't need any inputs because I'm not giving it information here. I'm asking it for information. And then I'm just going to return amount. So now I've got a simple method that just returns this variable. So now from over here in the tester, I can ask that account, what's your balance? It'll jump over here and it'll return that balance. Again, that's an example of a getter method. So if I wanted a getter method for the name variable, I would return a string. I would probably call it getName, and I would say return name. And then again, I could run it over here. I could say accounts.getName instead. Setter methods are just the opposite. A getter method will let the client code over here, the tester, it'll let the tester get the value of a variable, like see what it is. A setter method will let the client set the value of a variable here. So if I want to change the name or change the amount. So let's write one of those. Here I'll say accounts.set amount to 100. So what I want this method to do is I want to take this input of 100 and I want to set the amount to be 100. So public void, it's returning void because over here I'm not asking for information, I'm telling it to do something for me. And then I'll call it set amount. And because I have 100 here, I need to take an input that's a double. I'll call it amount. Maybe I'll call it new amount. That's more descriptive. And then I'll say this.amount equals new amount. Did I misspell new amount? Probably. So that's an example of a setter method. Most classes that you write are going to have getter methods and setter methods for most of the variables. Because you should be thinking when you're making any type of blueprint, like what would be useful for this object to have. Don't think about how you're going to be using the object for the particular program you're writing right now. Think about what in general would be convenient to have this object be able to do for you. And the most basic actions you'd want to do with an object are look to see what its variables are and change the values of those variables. So that's why we have getters and setters. All right, over here in the tester, let's go ahead and run some of the methods now. So I'm creating a bank account called Mr. D. Notice if I wanted to, I could create as many bank accounts as I want because this over here is a blueprint. So I could say bank account, account 2, new bank account, Mr. X. And now this is a completely different copy of the things in this blueprint. It's a separate bank account. All right, so I'm going to set the amount of my bank account. Well, hold on. Let's do this. I'm going to print out account.getBalance. So I'll see what the balance is. Then I'll tell my account to set the amount to 100, and then I'll print the balance again. So this is just like a very simple sanity check to see does this thing work the way we want it to. So here it's printed 0, and then after we set amount, it prints 100, and that's great. All right, there's a couple of things that are actually bad about this blueprint. I said that this was an insecure bank account, and it's insecure in several ways. So first of all, the fact that we made these variables here, these instance variables, public, means that actually you can change them without using getter and setter methods. So amount is a variable inside account, so I could say account.amount, and I can just set that variable directly, just like it was any other variable. This might seem convenient, and actually it is kind of convenient as long as you have a very simple class that only you're going to be using. This is generally considered a little bit dangerous practice, though, because there's nothing stopping the tester over here from doing whatever they want with this variable. The nice part about making them set the amount using a setter method is then you can control that process. You could make them give you a password, for example, or you could make sure that they weren't setting the amount to be a negative number, or they weren't setting it to be too large. So the first thing we're going to do here is we're going to change these public to be private. Notice that when they're private, oh, by the way, here, let me go back. All right, so I'm changing these both to private, and nothing's changed. Oh, actually it did change. It's all right, let me just tell you. So this asterisk up here, this star character, this means that the current file that you're editing has not been saved. And sometimes the compile time errors, these underlined in red things, they won't update until you save your files. So I just habitually hit Control-S to save my files all the time. And you'll see what's happened now that I've made these private. If I hover over account.amount, it says the field BankAccount.amount is not visible. Not visible means it can't be seen from the tester class because it's private. Excuse me. So this is forcing us to use getter and setter methods from the tester if we want to interact with that variable, and that's a good thing. So if I want to set the amount to 200, now I have to actually say set amount 200. All right, well, let's secure it in another way. Maybe I don't actually want to let anybody running this code set it to whatever they want. Maybe when you set the amount, you have to include a second input, which is the right password for the account. So let's extend the bank account class now by giving it another basic fact. If it's going to be password protected, we'll need it to have a password. So I'll create a new field called password. And let's say that when you first create the bank account, you've got to give the password as an input. So I'll take a second input here, and I'll say this.password equals password. And that takes the input variable password and saves it into the field password up here. All right, so now I'm gonna get rid of this other bank account object. All right, so now Mr. D, my password is P@SSWRD. It is an extremely secure password. All right, well, just because I've given it a password and I've saved the password, that doesn't automatically password protect anything. So here inside set amount, I'll need to take a second input as well. String pass for password. And I want to check it. I want to say if this.password.equals pass. Remember, dot equals is how you test to see is this string equal to that string. You might be used to thinking about it this way, like is this password equal to that password? Unfortunately, double equals signs only work for primitive data types like int and double and boolean. So dot equals is how you would actually compare strings or other types of object later on. So if they got the password right, then we'll set the new amount to be the amount. Otherwise, we won't do anything at all. So now here in the tester, I've got to give it, I've got to give it the password. So I'm going to give it a different password, also very secure. This is the password on my other account, 12345. And now when I run it, oh, I'm not printing anything. Okay, let's go back to printing things. So I'll print account.getBalance, and then here I'll print, All right, so now I'm running it, and it's 0, and then it's 0 afterwards because I didn't get the password right. However, if I get the password, and I run it again, now you see it's correctly run the method because it's seen that the password matches. Okay, if you're thinking that this is a little bit goofy because we can just see the password up here, yeah, you're right, this is a toy example. There's a lot of things about this example that aren't realistic, but I'm trying to illustrate why you might want to control the setter variables. If we really wanted to, we could prompt the user. We could say string response equals JOptionPane dot show input dialog, type a password. And then that's the password that we'll give to the constructor. And then when it comes time to set the amount, we could also prompt them for a password. And I'm going to prompt them just straight here inside the parameter, or inside the argument space. So type a password, 1, 2, 3, 4, 5. Second time type a password, hello, and we got nothing. Let's run it again. 1, 2, 3, 4, 5. Type a password. 1, 2, 3, 4, 5. And this time it's worked. Okay, I hope this has been helpful. Come back for one more example. We'll look at a very different kind of object and look at some slightly trickier methods besides just simple getters and setters. Okay, welcome back. As a second example of how to create a basic class, I'm going to solve the summer assignment of creating a point class that's intended to represent a two-dimensional point in space. So I've gone ahead and created a point class, and I've created a tester class where I'm going to instantiate. That means create an instance of. See how that word instantiate has that word instance at the beginning? I will instantiate the point class to create a particular point object that I can then do things with. All right, so point P equals new point, and then point P2 equals new point. Let's go ahead and create some instance variables. So the two fundamental variables I need to describe a point are its xy coordinate. So they'll both be private. I'm going to go ahead and declare them on the same line here, which is sometimes a nice practice. Next, I'm going to create the constructor. I want my constructor to take the coordinates as input. So I'll create a point at 1, 1 and a point at 6, 7, for example. So my constructor, remember, there's no return type, not even void, and the name needs to match the name of the class. And then the inputs need to match the inputs that I want to accept when somebody creates an object. So double X, double Y. You don't have to name them the same as the variables up here. So I'm going to call these A and B, for example. And then you could just say X equals A, And now there's no name ambiguity the way that there was before when these were both called x. Here, we don't know which x we're talking about. It's ambiguous, which is why I said this dot x. Whoops. Because the keyword this refers to the instance variable up here. I think that it's good defensive practice, even when there's no name ambiguity, to always use the this keyword when you're referring to an instance variable, just to keep it clear. But it's not necessary. The compiler doesn't require it. All right, so there we go. We've got our point constructor. Let's go ahead and rapidly create the getter and setter methods, which is what you'll pretty much do every time you make a new class. So public double get x, return x, public double get y, return y, public void set x, new x, x equals this dot x equals new x, and oops, public void set y, double new y, this dot y equals new y. Okay, so we've got our getters and setters. So those are the most basic things, but let's create some methods that encapsulate some more sophisticated behavior. So I think a method that would be convenient to have is a method which will calculate the distance between 2 points. So the distance is likely to be a double. I'm going to call it getDistanceTo, and as an input, I'm going to take another point called other. So here's the way that you should visualize this. Right now I'm just going to return 0 to get rid of that compile time error. All right, so the way that we'd use this is I'd say something like p, which is a point, and then I'd have the point run the getDistanceTo, and then I'd give it p2 as the other point. So p2 is this point object. I would take a reference to this object, and that reference gets copied here. So inside the blueprint, whatever I'm doing here is really operating on this point p2. Of course, we would expect to get the same response if we did get distance to p, because distances are reciprocal like that. Notice getDistanceTo returns the distance. It's not going to display the distance, so we would actually need to create another variable here to store the return value, because otherwise it's just returning to nowhere. All right, let's go ahead and get the distance using the distance formula. So the distance formula is the difference in x squared plus the difference in y squared, and then take the square root of that. So I'm going to create an xdiff variable, which will be my own x-coordinate minus the other one's x-coordinate. I think it's good practice to use the getter methods. It's even good practice to use a getter method for your own object, this.getX. The reason why is because later on, if you want to change, this object's very simple, so we're probably not going to, but in a more complex object, you might want to change how you're representing the information. So if you always access the information using a getter method, you're free to change how it works underneath, and you're not going to break any of your own code. If that didn't make any sense, probably don't worry about it too much, and we'll get to an example where it does make sense. So the y difference is the difference between my y-coordinate and the other one's y-coordinate. And now I'm going to return the square root of each of those squared. So a lot of people were using math.pow to square things. So xdiff and then raise it to the power of 2. That'll work, but math.pow actually is very, very slow to run. If you're doing something as simple as squaring, it's going to be a lot faster just to do xdiff times xdiff. I think it also looks cleaner because you don't have all of that. Whoops. You don't have all of that math dot stuff in there. All right, so there's distanceTo. Usually it's good programming practice to test as you go. Really good programming practice is to write a bunch of tests ahead of time and then run them every time you make a change. That's called test-driven development, but we're not going to do that right now. Instead, we'll just test as we're going. So I've got a point here, I've got a point here, I've got distanceTo. Let's print it and see what it says. Okay, well, it's definitely returning a number, and that number doesn't look insane. It doesn't look obviously wrong. It's probably a good idea to double check that it's actually the right distance. So I think what I'm going to do is I'm going to I'm going to create 2 points where I know the distance between them. Oops. I'm going to create a 3, 4, 5 right triangle. So I know if I got a point at the origin and I've got a point that's over by 3, up by 4, that the distance is the hypotenuse of the triangle and it should be 5, and so it is. So, am I guaranteed that this method is bug-free? No. This was just a sanity check to make sure that it's returning what I expect for one of the most basic expected cases. Okay, let's go ahead and write the isRightOf method. isRightOf point other. And the idea with this method is this is going to return true if the point that's running the code is to the right of this other point. To the right of means its x-coordinate is larger. So a lot of people wrote a basic if statement. They said if this dot x is greater than other dot x, then we'll return true, like this. Otherwise, we'll return false. Okay, something like this. This will work, but this is no professional programmer would ever write this because this is actually 4 more lines than it needs to be. So let's make this observation. This thing inside the test is what's called a Boolean expression because it's an expression that returns true or false. It's like a test. We're asking, is this thing true or false? So instead of putting the test in an if statement, we know it returns true or false, so we could create a variable called test. So it's still going to run this test. It's going to ask the question, is this larger than that? And the answer on the right-hand side here is going to evaluate to be true or false. But that value now is going to get saved inside this variable. I kind of like to put parentheses around this. I don't know, I just think it looks better. Notice that isRightOf is supposed to return true if this test was true. And it's supposed to return false if this test was false. So I can really just return whatever's inside test. Because if the test was true, I would want to return true. And now that we've put it this way, you'll notice that there's actually no point in saving the result of the test inside a variable because I'm just going to return it anyway. So in fact, the shortest answer here is I'm just going to return the answer to the question. Oops. I'm just going to return whether or not this is larger than that. And this is a good way to think about it in your head. I would encourage you to try and translate this to English whenever you're writing your own Java code. So the isRightOf method is asking, am I to the right of this point? And I'm going to return whether this is true, whether this is greater than that. So that's the trick. Think, I'm going to return whether this is true. All right, let's write the last method now, which is a method called isCloseTo. All right, so the way isCloseTo works is it takes a point as input, and then it takes some distance. We'll just call it dist, I guess. So isCloseTo, well, being close to something is kind of subjective, right? So that's why we provide a distance. What this method's really going to do is it's going to test to see, is this point within a certain distance of this other point? So if this distance is 3, I'm testing, am I within a distance of 3 of that other one? All right, so what a lot of people did is they got out their copying and their pasting, and they went ahead and they calculated a distance, and then they have their if statements where they're saying, and they're saying, or let's call this real dist. And so then they're saying, if real distance is less than distance, then I'll return true, otherwise I'll return false. Okay. So again, this would work, but this is now many, many more lines than it needs to be. And it's not just about making your code short, it's about making your code just blindingly simple to look at and read. So if you see this, you got to think, like, what is this doing? Oh yeah, it's calculating the distance, and what's this about? You know, you got to look at it line by line. Instead of copying and pasting this code from up here, go ahead and just use the method you already created. So we could say double real dist equals get distance to other. If you wanted to be explicit, you could say this.getDistanceToOther, because this is the current executing object. All right, and then instead of this, remember what we just talked about here? You can just return the result of the test. I don't want to say if this test is true, return true. If it's false, return false. Instead, I just want to return the result of the test directly. So this is great. We've reduced it to 2 lines. So I find the real distance, and I return whether the real distance is less than this distance. Okay, but I could even make this one step shorter. I don't need to save real distance into a variable. Instead, I could just return, is the distance to the other one smaller than this threshold distance? And so now I've got sort of a one-line solution. Okay, these are the kinds of tricks that are going to make you, I mean, they're not tricks, but these are the kinds of practices that are going to make you a better programmer. This is the difference between kind of being a kid messing around and starting to develop the skills of a true developer, where you could actually make production quality code that other people would take seriously, and that you would have some confidence that it works and that you could easily extend it or modify it without breaking it. Okay, thanks for coming. If any of this was new to you, I would recommend maybe creating a couple of other classes as practice, and I'll post some recommendations for practice that you could use.